Hello everyone, welcome to our next lesson. Today we're going to look at the relationship between lines. We're going to be looking at both lines that are in two-dimensional space and three-dimensional space. If they're in two-dimensional space, three things could happen. Either they intersect, they're crossing each other, or they're parallel like railroad tracks, or they're coincident. Essentially, two lines are the exact same. Also is possible when we get to three-dimensional space, they could be either coplanar or skewed. They're coplanar if they lie on the same plane, and they're skewed if they do not lie on the same plane. For example, this image that we have here. So typical questions we would see from IB would be something like this. You have line 1 and line 2, both two-dimensional space, and you want to find where they intersect. So if you want to find where they intersect, where two lines intersect, what you need to do is to find the x value and the y value that is the same for both equations. So this line, what x value is equal to this x value? So that's essentially what we're going to do. We're going to make the x value, which equals negative 2 plus 3s, equal to the other x value, which is 15 minus 4t, and the y value as well equal each other. I'll put that here. Y is equal to 1 plus 2s, which is also equal to 5 plus t. And if you just look at this part and this part, what you've got is two equations with two unknowns. So if I play around with this equation, I've got 3s plus 4t is equal to 17. And if I look at this equation, I've got 2s minus t is equal to 4. So I'll call this equation 1 and equation 2. I've got equation 2, so what I'm going to do is I'm going to multiply equation 2 by 4. So I've got 3s plus 4t is equal to 17. Multiply equation 2 by 4, we get 8s minus 4t is equal to 16. And then because these are opposite signs, we're going to just add them together. That eliminates the t, so we get 11s is equal to 33, and therefore s is equal to 3. And I can plug this s into this equation to figure out the point where the two lines intersect. So what we get is xy is equal to negative 2, 1, plus 3 times 3, 2. And that gives you xy is equal to 9 minus 2 is 7, 1 plus 6 is 7, 7, 7. And therefore they intersect at the point 7, 7. If you're wanting to check to make sure that this is correct, you could continue this on instead of just plugging into the answer. You could have figured out what t is. So when s is equal to 3, let's go to equation 2. So 2s minus t is equal to 4. Well, if s is equal to 3, then 6 minus t is equal to 4, and therefore t is equal to to 1. 6 minus, no, 4, sorry, t is equal to 2. And if we plug that one into this line, we get xy is equal to 15, 5 plus 2 times negative 4, 1. And this is equal to 15 minus 8 is 7, 5 plus 2 is 7. Lo and behold, they're the exact same. And that's where they intersect at 7, 7. Another kind of question that they would ask would be something like this, where you've got two lines that are in three-dimensional space, and let's just do B for time's sake. Show that these lines are skewed. Now, to show that two lines are skewed, one, you have to show that they don't intersect. Okay? Like this line and this line don't intersect. But that's not enough. You also have to show that they're not parallel, because if they're parallel, they don't intersect, but they're still on the same plane. Okay? So for this one, what we're going to do is we're going to look at line 1 and line 3 and first find out that they don't intersect. So looking at the x values of 1 and 3, remember we're just doing line 1 and 3. So negative 1 plus 2s is equal to 1 plus 2u. And for the y value, 1 minus 2s is equal to negative 1 minus u. So 2s minus 2u is equal to 2. And negative 2s plus u is equal to negative 2. We put them on top of each other. So 2s minus 2u is equal to 2. Negative 2s plus u is equal to negative 2. And then we're going to add these together. We get negative u is equal to 0. And therefore u is equal to 0. Now that we know that u is equal to 0, what we're going to do is we're going to plug it into, let's call this equation 1 or equation 2. Let's plug this into equation 2. So negative 2s plus 0 is equal to negative 2, and therefore s is equal to 1. Okay, so we figured out where they intersect in the x and y value. Plug that into equation 1 and 3 and see if the y value also gives an intersecting point. So if we plugged in u equals 0, we get into equation 1, line 1, so line 1, we get the z value is 1 plus 4 times s, and s is equal to 1, so 1 plus 4, which is equal to 5. But for line 3, the z value is 4 plus 3 times u, and u is equal to 0. And this equals to 4. 5 does not equal 4, and therefore they do not intersect. So you found that they do not intersect, but we also have to check that they're not parallel. So what you're doing is next we're going to look at the slope, or not the slope, the direction of line 1. So the direction of line 1 is 2, negative 2, 4. And the direction of line 3 is 2, negative 1, 3. And the question is it possible to do a multiple of one line, or one direction of a line, equal to the direction of the other one? And clearly it's not, because if m equals 1, this is equal to this, but this wouldn't equal to this. And therefore they're not parallel, and do not intersect. Sorry for the writing. And therefore they are skewed. Hope this helps. Have a good day.